to start with a line from the report that I think is going to set the tone for everything we're going to discuss now. And it reads as follows. In robotics, machines perform only as well as the minds that design, program, and maintain them. So in light of this sentence, we should be able to see how the continent's wealth is not only in gold mines and in agriculture, it's also in its youth that is making the majority of the African demographics. So it's making the majority with over 60% of the population, and we're being in a range of under 25 years of age. So hence, there should be no doubt that investment in people is investment in robotics. The report addresses the education and training systems that is needed to have an advancing robotics ecosystem. And it describes it as a cradle-to-career pipeline. And the pipeline basically starts with an entrance to the primary and secondary education. And it exits in some countries with undergraduate programs and workforce. So joining us in this panel are two speakers that each oversee a different stage of this pipeline. One of our speakers oversees its entrance, working with children as young as 4 years old in Mali. And the other speaker is at the most advanced end, educating the next generation of robotics and AI engineers at the graduate level, formerly at Rwanda, currently at Pittsburgh, Pennsylvania. So I would love to welcome our panelists, Michael Leventhal, the principal investigator and founder of RobotsMali AI4D Lab, and he's such a great entrepreneur and a great business leader. And I would like to welcome Professor Conrad Tucker. He's the trustee professor of mechanical engineering at Carnegie Mellon University, Pittsburgh, Pennsylvania. And the former director of CMU Africa. And this university was one of the institutions that was explicitly recognized in the report for integrating AI and robotics at advanced level across the African continent. So please welcome the panelists. Are you with us?
I'm here.
I can hear you.
This is Michael. I'm here.
Hello, Michael. Do we have Professor Conrad?
Yes, this is Conrad. Can you hear me and see me?
Yes, hello, Professor. So before we get into the serious questions, I would love to ask you, how are you feeling getting into the conversation? Are you feeling optimistic? Do you have a pragmatic sense of how this is going or where this is going?
Well, first of all, I'd like to thank this panel for the opportunity to share my views on robotics in Africa. It's really an exciting time to be in the robotics field as the field itself is growing and Africa is really poised to contribute globally to the robotics ecosystem. So thank you very much for the opportunity.
We are very pleased to have you. Michael, do you have an opinion?
My philosophy is, I call it positive pessimism. So we encounter many problems in Mali. It's maybe a uniquely difficult environment to work in, but we've been here for 11 years and we're still going strong. So I think things are working and they're working more and more. So
I love that. Positive pessimism. Okay, so as an introduction to myself, hello, my name is Bahga Mohammed and I am a Cairo University graduate. I'm a distinct graduate of year 2025, freshly out of the pipeline actually, and currently I work as a robotics engineer with SilverKey Technologies. As a reminder for our audience, please use the chat if you have, please use the Q&A feature actually if you have any questions. And we will be having the last 10 minutes to address those questions. So we're gonna take a brief time to focus on Michael with the first question. And please, Professor Conrad, be with us because I'm going to ask you something that is based off the points that may be risen by Michael. So The report identifies early childhood exposure as foundational to build the robotics pipeline. So, Michael, we know that for young children, the decision makers are the parents. So how do parents get convinced, or what is it that convinces the parents to enroll their children into a robotics program, sometimes as young as 4 years old?
Well, it's difficult because we have a school system that has not yet embraced robotics education, or I mean, curriculum is very out of date. It's very rigid, and parents, of course, want their kids to succeed in school. So for some parents, it's what we're doing is nonsense, and they don't see the value. But increasingly, that's less and less, and more that do see the value. The educational system in Mali has not been successful. It's certainly not been successful in creating a prosperous country. And even the Ministry of Education recognizes that they have a lot of work to do. And the parents are seeing that increasingly, and it's building quite a lot of momentum too. We had maybe a small number in the beginning, but those kids have done really well. The parents see that they think differently. Sometimes those parents turn out to be very influential people, sometimes government officials, sometimes leaders in industry, and they influence a lot of people. So I think the idea of what we're doing is kind of fundamentally strange, given the situation that has existed and the incentives in the system. But it's working over time, it's spreading, and we may even be seeing exponential.
Is the network down from my side?
I think it's back on.
Okay. For the time being, is Michael still with us?
Yeah.
Oh, okay. Please continue.
Oh, I think I said, unless there's some kind of follow-up. I'm trying to keep it not, I can talk at great length, but we only have a short time.
Yeah. So Professor Conrad, are you with us?
Yes, I'm here.
Okay, so my question is built on what Michael have said. He's a positive pragmatic, so a realistic view to the situation on ground. But from your view, what are the skill sets that are needed to advance through the pipeline since its entrance to its exit?
Yeah, so I think there's an opportunity to reframe how we think about robotics so that it's not this isolated field. There are many transferable skills and knowledge that you can take from one domain to the other. So let's take motion planning algorithms as an example, or linear algebra. Learning these in the context of robotics could be then applicable to other fields like artificial intelligence or mechanical engineering. So if we see robotics as contributing to the broader ecosystem of STEM, the hope is that there's broader appeal and adoption when it comes to education and workforce development.
Amazing. Okay, so Professor Conrad, a question I think directly to you, but Michael, if you have any takes on it, please go forward. So the report shows that across Africa's robotics-related university programs, undergraduate and postgraduate, mechatronics dominates with 85.2% of the program focus, with only robotics and AI-related specializations taking account for just 14.8%. So is that balance going to hinder any progress in the robotics ecosystem?
Well, I think mechatronics is a great crossroads because it provides hands-on tinkering, which I think is absolutely critical in the field of robotics. What I think is needed is to help educate students on the broad skill sets they're able to develop um, by having mechatronics and other courses available to them. Yes, there seems to be a skewed nature towards mechatronics, but I think those hands-on tactile skills are also then transferable to other domains. I may add that maybe one thing that we may want to encourage more of, and you see this in other disciplines, is just more robotics competitions. And I think this is where the skills of mechatronics could really be highlighted if students are building things, building robots, and those robots or those teams are competing, and the entire field and knowledge is advancing. Thank you.
The report actually agrees with you, Professor Conrad, on the robotics competition and its importance. So great take. Michael, I see you are raising your hands.
Yeah, just a little word to add about it. So in Mali, we've had mechatronics in our engineering university for many years, but it's a very outdated program. It's automatism. There's no modern robotics or artificial intelligence or anything like that. What we've been doing is, so we've run the last 6 years Indaba X Mali. One of the speakers mentioned deep learning. Indaba now has some kind of robotics group or discussion, perhaps this year. The Indaba X is the national chapter of sort of deep learning Indaba. And we go every year into a different university, and we do a lot of activity for the students. Our approach is grassroots, so we're trying to create a demand for the universities to start teaching AI and start teaching robotics, and we are seeing traction in that. The Indaba X has really been our tool to build the awareness and get the university people to take notice that they need to offer better programs and programs at all in these areas.
This is exactly what we need. So another point that the report have mentioned is that there is a golden ratio that I've never seen anywhere else. And first time that I come across this ratio was actually in the report. So I really encourage everyone to go download the report. So the International Labour Organization had this ratio 1 to 5 to 25. And it basically means that for every engineer, there should be 5 technicians and 25 craftspeople, such that we can convert designs into functioning systems to sustain innovation. So speaking on Egypt's level, and I'm sure it's also continent-wide, there is a bias towards engineers and engineering degrees over the technician diploma or technician degrees and over craftsmanship in general. So what are your thoughts on this? Of course, we should be moving to the golden ratio by the ILO, but any thoughts?
Sorry, is the question directed?
If you have any points, of course, go forward.
Sure. I think this is a very important point, and I think it's more of a cultural shift that is needed, a societal cultural shift that perceives technicians as valuable, prestigious members of society. When you look at Germany, for example, they're well-established academic systems, but a lot of vocational and technical training, and there are many successful career pathways. And you can start off with, let's say, technicians, and at some point switch to, the traditional academic engineering degree. And I think so that type of societal and cultural shift would really be invaluable in helping to expand and meet these ratios.
So do you think that there are countries who are pushing forward for firstly the students in the pipeline going for technician roles or technical roles and then proceed to research roles. Do you have any examples in mind?
Not where we need to be. So I think one measure of success is when we see even an event like this, or at an African Union event, where we invite a technician to be a panelist, right? So if we want these changes, we have to take the action and interventions to make it happen. So I would love to see in a future panel to have a technician as a panelist who's worked repairing cars or robotic assembly lines to provide their perspective of what it means to be in that job and in that career path.
Kene, I hope you're taking notes. Okay, Michael.
Yeah, so we've done a lot of education. We started with kids. Our first activity was a STEM camp for kids with robotics as kind of a major theme. Maybe it's a chance to mention now that in our first robotics camp, we used the affordable education robot, which was one of the outcomes of the initial African Robotics Network in the search to find low-cost robotics robot or tools for education in Africa. And we used that for many years, and it was quite wonderful. So it's amazing to see this continuing now and taking up that work that really got us started. But we really never set out specifically to create engineers or researchers. We started with the idea to give kids the skills and the vision and motivation and to build the country, to contribute to the development of the country, and also to stimulate their brains, to do things that they don't do in school that would be fun and interesting and just stimulate brain cells that weren't getting stimulated. And there are now many thousands of kids that have passed through our programs in 11 years, and it's not many of them have become researchers. A few definitely have, and more engineers. So we built that pipeline for the most research or academically oriented, certainly, and we do identify the talent and we nurture them. But all those other kids that have gone through are just as important, and they have many skills, no matter what path they choose, that can contribute.
Thank you very much for the insights. I would like to, so are there any questions to be taken, or can I ask one more question before we can take questions from the Q&A?
You can go ahead, Bahga. We don't have questions.
Okay. So I would like to ask about the role of inclusivity in the robotics ecosystem and in the robotics workforce. So sorry for the gardening equipment. Very good timing for it. Can you hear me properly?
Yes.
Okay. So the report highlights across many African countries that fewer than 25% of STEM graduates are females, and that representation drops down even further in engineering and technical roles. So what does Africa's robotics future realistically look like if that representation gap was never closed?
I would say the future would be bleak if that gap were never closed. And we need to close it. And we need to close it by not just talking about it, by taking action to understand what are the cultural barriers. What happens from, you mentioned 25% to even a drop when it comes to STEM. What is it about the STEM discipline that is becoming a deterrent for women and young girls who are very interested at a very early age, but then something happens down the road? I do think, again, going back to these kind of use-inspired competitions, where you pick a topic that is of interest and have women and young girls participate in a robotics competition to just raise awareness at much earlier before they even choose their STEM careers. In addition to women, there are many different marginalized populations that could also benefit from being in the robotics ecosystem. Refugees, people with disabilities. One project that has been very successful at CMU Africa was a prosthetic hand for amputees from war-torn regions in Africa. So what started as a disabilities project turned into a competition where students were building these robotics hands and learning how to cook jollof rice. And so there's a competition. It might be the first jollof rice cooking robot hand. So I think those kinds of competition really, and yeah, you should look at, I see there's some laughs, you should look at on the online videos, but I think cultivating this ecosystem of collaboration and competition really will expand to marginalized populations, including women. Thank you.
This is very spot on. We do not talk enough about people with disabilities and refugees taking part in the workforce. So thank you very much for this. Michael, what takes are you taking today?
Yeah, so we have observed something which is interesting, that when we do our training programs or our camps or activities in robotics at the younger ages. So we previously started at 4th grade. Now we're starting even younger, but the girls outnumber the boys, okay, through elementary school, and the numbers fall off as you get higher. So it's fewer girls in middle school, and then by high school we're seeing the 25%, and then in university it's probably half that again. So that's just an observed phenomena. I think there are cultural factors. There's a lot of things that we can talk about, but we just keep making our programs accessible, encouraging participation of girls. So last year we participated in the International Olympiad for Artificial Intelligence. And the team of 4 had 2 girls, and one of the girls was first in the category that she competed in the world. So those kinds of things, making those things possible, giving the opportunity, and I think things do change.
Honestly, it's shocking that it starts off as a girls' majority and then it drops out. I wonder what is driving that. We have 5 minutes left. There is a question from the chat that maybe we can address really quickly. So it says robotics talent needs both the AI software side and the embedded hands-on hardware side. Which half is harder to find locally, and which half are universities actually producing? Very good question. Who would like to go first? Conrad, would you go first?
Sure. So I think in the advent of cloud computing, universities have been quite successful in producing AI talent and software engineers that are able to train models because the infrastructure can be remote. But when it comes to the physical hardware itself and embedded systems and edge computing, we see more bottlenecks because that requires the physical fabrication and assembly of the embodied AI systems, so the robots in-house. And so those are areas that we should definitely improve on the physical and embedded systems. Thank you.
Thank you, Conrad. Michael, do you have something to say about this point, about this question?
Sure. Well, we do both. We're a member of the AI4D network, so we're doing lots and lots of AI. We started with robotics, but now we do just as much or maybe more AI. As the professor said, the resources, and actually in both areas, are a big problem getting the hardware into our country. That like Arduino is wildly popular, but if you want to go anywhere beyond Arduino, then just getting the equipment is a big challenge. The AI, it's the access to compute resources and good internet connections. It's almost as big a problem. But we have the students interested in both areas, and we have lots of people working in both. Of course, AI and robotics today are inseparable.
This is very, as if you're talking about Egypt, we have shared challenges. And I see as if the countries are mirroring each other. So we have 2 minutes for the end of the panel. I would love to take them to thank both of our panelists. Thank you, Michael. Thank you, Conrad, for joining us today. Truly rich insights and truly rich answers and experiences. I would also love to take the opportunity to highlight again the report that to the audience that please go read it. There are way more points to be discussed and way more points to be raised. And the report highlights a lot of challenges, and I think that we should be having more conversations about the challenges and the negativities within the workflows and talent pillar of the ecosystem, because this is how we move forward. So thank you all. I'm gonna leave you now with a break.